In the course Mass Transfer in Environmental Engineering, the student is asked to estimate gas and liquid diffusivities. A recurring student error on the exam is to be confused regarding when to use the equation for gas diffusivity and when to use an equation for liquid diffusivity. First things first. If you only have one molecule, you do not have a gas and you do not have a liquid. For something to be in a liquid or gas state, you have to have several molecules. Secondly, if someone asks you what is the diffusivity of substance A in substance B, what is usually implied in that question is that you have trace amounts of substance A and a lot of substance B. Thus, if I ask what is the diffusivity of nitrogen in water at 20 degrees centigrade, you should first ask yourself, what is the state of water at 20 degrees centigrade? Since the question implicitly communicates that water is the substance you have a lot of. Water is a liquid at 20 degrees and atmospheric pressure, so thus you should use an equation for diffusivity in liquids to answer the question. The fact that nitrogen is a gas at this temperature and pressure is of no relevance. Many gases can be dissolved in liquids, but when the gas is dissolved in a liquid, it is no longer a gas. Compare a beer bottle. Before you open the bottle, most of the CO2 in the bottle is dissolved in the beer. Once you open the bottle and reduce the pressure, bubbles start to form and you have a heterogeneous system, a mixture of gas and liquid, still with some carbon dioxide dissolved in the liquid. When we are talking about diffusion in liquids, we are not talking about how gas bubbles behave in a heterogeneous system. We are talking about how individual molecules move around in the liquid. If I instead ask what is the diffusivity of water in air at 1 atmosphere and 20 degrees centigrade, it is implied that it's air that you have a lot of. Air is a gas at 1 atmosphere and 20 degrees, and thus you should use an equation for gas diffusivity to answer the question. The fact that water is a liquid at 1 atmosphere and 20 degrees is irrelevant. Water, as most liquids, have a non-zero vapor pressure at 20 degrees, and thus some water molecules can exist as a water vapor in the air. Note, when we are talking about gas diffusivity, we are not talking about how droplets of liquid move around in a gas. We are talking about how individual molecules move around in the gas. On exams, I usually ask clearer questions than the ones I've asked in this video, but I still think that a student of mine should be able to understand the implicit information in the questions I've asked in this video. Please note that for liquids, it's crucially important to know which substance you have a lot of. The diffusivity of trace amounts of water in ethanol is not the same as the diffusivity of trace amounts of ethanol in water, since ethanol and water have different viscosities. At a given concentration of water in ethanol, however, the diffusivity of water in ethanol and ethanol in water are the same, since the ethanol molecules can't be mixed with the water molecules if the water molecules are not mixed with the ethanol molecules. For gases, the concentration usually does not matter. If it is an ideal gas, the only interaction between molecules is when they collide with each other. So we should expect that the diffusivity of trace amounts of nitrogen in oxygen to be essentially the same as the diffusivity of trace amounts of oxygen in nitrate.